Hey guys, today I will teach you how to use Solver Excel and GoalSeek in solving chemical engineering problems. So problem number one. So our problem is a shipping company has the capacity to move 100 tons of cargo per day by air. The company charges 250 per ton for air freight. Besides the weight constraint, the company can only move 50,000 cubic feet of cargo per day because of limited volume of aircraft storage compartments. The following amounts of cargo are available for shipping each day. So, in cargo 1, the maximum tons or the maximum weight the cargo one can ship is 30, and the volume it occupies is 550, and the second cargo is 40 weight tons and its volume is 800, and the cargo 3 is 50 tons and its volume is 400. So the required here is to maximize the profit for the shipping company. So the required here is how much the profit of the company is, or how much, right? Maximize. So to solve this problem, I already put the equation here so that it will not we will listen time. So our equation is we let x, y, and z the amount of tons the cargo can ship in cargo 1, 2, and 3 respectively. So the x, y, and z here is the amount of cargo 1, 2, 3, or the maximum amount of cargo can ship. And our objective here, it is stated in the problem that um, the company will charge $250 per ton. So because x, y, and z is the amount of tons, so if we add x, y plus z, and if we times 250, it should be equal to the maximum profit. So that is our objective. So we have also 5 constraints here. So the constraint 1 is, it is stated in the problem that the shipping company has a capacity to move 100 tons of cargo per day. So if we add x, y plus z, it should be equal or less than 100. So that is our first constraint. And the second constraint is the volume of the cargo 1, 2, 3 is 500, 800, 400 respectively. So we have this 500x plus 800y plus 400z should be equal or less than 250,000, because it is stated in the problem that the company can only move 50,000 cubic feet of cargo per day. And our constraint 3 is x should be less than or equal to 30, because the maximum weight tons the cargo 1, 2, and 3 is this 30, 40, and 50. That's why we have this. Y should be less than or equal to 40, and z should be less than or equal to 50. So to solve this using Solver Excel, we must put first the equations, the coefficient of the functions, or we must first input the equations without the variables. So we have decision variables, which is x, y, and z, and we initially let the value of x, y, and z 0 and 0, and we have objective. Our objective here is this 250 times x plus y plus z should be equal to maximum profit. So if we substitute 250, we have the coefficient of x is 250, also the coefficient of y is 250, and the coefficient of z is 250, and the total, and its total should be the maximum profit. So if um, we multiply 250 times the x plus the 250 times the y plus the 250 times the z will be the maximum profit. So the value here is 0 because we let the x, y, and z is 0. So if we times 250 times 0 plus 250 times 0 plus 250 times 0, so the answer is 0. We so now the constraint, we write the constraints in 1, 2, 3, 4, and 5. 3, 4, and 5. So in constraint 1, we have this x, y plus z should be less than or equal to 100. So the coefficient of x is 1, the y is 1, the z is 1, should be less than or equal to 100. And the second constraint is we have the coefficient of x 550 and the y is 800, the z is 400, should be less than or equal to 50,000. Third constraint, which is x, which is 1, and we don't have y and z, should be less than or equal to 30. And our fourth constraint is just y, which is 1, should be less than or equal to 40. And our fifth constraint, which is only z, 1, should be less than or equal to 50. So we can now use here um, in this if we multiply this one, our constraint 1 to the decision variables, its answer is 0. So we can just drag it down. Why is it 800? Oh, I forgot to put dollar sign. We must first put dollar sign in order if we reference it, it will not move down. If we drag it down, oh, the answer is 0. So here, so we now have the value. We have the total of the constraint 1 is 0, 0. Constraint 2, 3, 4, 5 is 0 because we let the initial value of x, y, and z is 0. So we can now use solver. So to use solver, just go to data, click solver, and here it is stated here that set objective. So if the objective we set is the total here, and it is stated in the problem that to maximize the profit of the shipping company. So we click the maximum here by changing the variables this, and the constraint here is we add constraint, and the constraint here is the cell reference is this one. The total of the constraint 1 to 5 should be less than or equal to this one. So if we click OK, and then simple if we click sample options, if we have 100, 100, okay, then if we click solve, then the solver found a solution which is the maximum, or to maximize the maximum profit is 24,218.75. This is the maximum total, and the maximum amount of x, y, and z, or the maximum amount of cargo 1, cargo 2, and cargo 3 respectively is this. So that is our answer. So we proceed to problem number 2 in using Excel solver to solve the problem. So our Problem number 2 here is solve the following system equation using solver function. And we have this equation, which is equation 1 is 2x plus 4y plus 5z minus 33 is equal to 0. Equation 2 is 6x plus 6y plus 7z minus 70 is equal to 0. 3x minus 6y plus 4z plus 71 is equal to 0. So to solve this using Excel, um, I already put this the given and I transpose the 33, the 70 and the 7 to the right side, and we come up with this. So to solve this, um, we write the decision variables, which is x, y, z, and um we let the initial value of x, y, and z to 0, and our constraint, and we have three constraint here, which is this equation 1, equation 2, and equation 3. So we have constraints constraint 1, 2, and 3. And our constraint 1 is the value of x is, or the coefficient of x is 2, and the coefficient of y is 4, and the coefficient of z is 5. And in constraint 2, the coefficient of x is 6, and the coefficient of y is 6, and the coefficient of z is 7, and the coefficient of, in constraint 3, the coefficient of x is 3, the y is negative 6, and the z is 4. And it should, and the total of these, and the total of the constraint 1 and 2 should be equal to, um, should be equal to 33. 33. And in constraint 2, the total should be equal to 70, equal to 70. And in constraint 3, the total should be equal to negative 71. So to get the total here, we just use the sum product, and we highlight the constraint 1, comma, and highlight the decision variables x, y, and z, and we click enter. Also for the constraint 2, we use sum product, highlight the constraint 2, comma, and highlight this variable, enter. And in same for constraint 3, sum product, highlight the constraint 3, comma, and the decision variable, enter. So because we now have the total here, so we can now use the solver. So we click solver and set objective, and we set objective this one, maximize. Then by changing the variables, this x, y, and z, and oh I will delete this constraint here. So subject to the constraint, so our constraint here is this one, so we add, and our cell reference here is this one. The total of constraint 1 should be equal to this one, so we click add. And also this one, or the total constraint, the total constraint in 2 is should be equal to this one, click add. And then the total constraint of 3 should be equal to this one, so we click OK. And then sample LP option to 100, OK. And then if we click solve, then the solver found a solution, which is the value of x, y, and z is 6, and the y is 11.5, and the z is negative 0.5. So this is the final answer. So That is problem number 2. So let's proceed to problem number 3, which is we use goal seek in solving the problem. So our problem here is find the specific volume of N-butane at 500 Kelvin and 18 atm using the Redlich-Kwong equation of state. So we are given here the working equation to solve the specific volume, and we have also the equation to solve the A, the B, and the reduced temperature and the alpha. And we are also given here the critical temperature, which is 425.2 Kelvin, and the critical pressure is equal to 37.5 atm. Also the value of R, which is 0.08206 cubic meter atm per gram per mole Kelvin. So this they meron to siyang cubic meter here. So to solve this using goal seek in Excel, so here I just put already the given here to minimize the time. So we have we are required to use the equation which is Redlich-Kwong. Our system is in butane and our working equation is this. And our parameters, the given parameters are the temperature, which is 500 Kelvin, the pressure is 18 atm, the critical temperature is 425.2 Kelvin, and the critical pressure is 37.5 atm, and our real real gas constant is 82.06 cubic centimeter atm per gram mole Kelvin. So the R here is I just convert it to cubic centimeter because in the given it is in cubic meter. So because I want the molar volume or the specific volume to be in cubic centimeter, so I convert it to cubic centimeter, which is 82.06. So solving for the A, B, and the alpha and the TR, we are already given we are already given to solve this, and these are the equation, which is TR is equal to temperature divide the critical temperature, which is 500, divide the critical temperature, which is 225.2, enter, and we have this value. Also the alpha, which is 1, divide the TR to the zero point 0.5, and we have this value, and also the alpha, which is equal to 0.42748 times the r squared times the critical temperature squared divide by the critical pressure time all over times the alpha, which is this one, and we have this value. And solving for B, we have 0.08664 times the R times the critical temperature divide the critical pressure. I just made pressure here, divide the critical pressure. Okay, divide the critical pressure here and enter. Okay, and we have this value. So now we can now solve for V. So solving for V, which is we have this equation, we have this working equation, control C, we have this. Okay, we have this equation. So we can see here that we cannot solve for v because we don't have the initial value of v. So to get the initial value of v, so we use the ideal gas equation. So I will just put here ideal gas equation, which is PV is equal to RT, right? So to solve for V, we just manipulate the equation, which is V is equal to RT over P, right? Because we know the values of R, the temperature, and the pressure, so we can now solve the initial value V so that we can solve the final volume or the specific volume V. So to solve for the value of which is equal to RT, we can RT, so we have R, we have this value times the temperature, which is 500, all over divide by the pressure, which is 18. So enter, and we have this initial value of V. So we can now solve for the specific volume, which is V. The initial value of V is 2279.444, and the f of V, which is this equation, Control C, we just copy this and we just replace the values, which is the V, this one, the initial value of V, the value of P, the V here, the R, the T, the V, the value of V, the A, the P, the B, R, times the temperature times the B minus the A times the parameter B, and we click enter, and we have this value of f of V. So to solve the final specific volume, we use goal seek. So to use goal seek, we just go to data, click what if analysis, click goal seek, and it is stated here that set cell. So we set this one to value 0, so that by changing the value of this one, the value of V, so the result here is the final specific volume of N-butane. So if we click OK, so the answer is 2037.6888721. That is our final answer, or that is the specific volume of butane using Ridley-Kwong equation. So that's it. Thank you for listening. God bless.